Good morning, students. In the last class, we discussed on the topic that is motional electromotive force, right? That is motional EMF. So we derive the relation that is induced EMF E across the ends of the conductor E, that is equals to BLV, where B is the magnetic field, where L is the length of the conductor, and V is the velocity, right? So for that we considered uniform magnetic field. So in this uniform magnetic field, we considered one rectangular circuit or rectangular coil or rectangular loop. So PQ or this. L is the length of the conductor and X is the breadth of the conductor, right? So in this rectangular loop, we have four arms, that is PQ, QR, RS and SP. Out of all the four arms, one is movable arm and all the three arms are remains stationary, right? So movable ಅಂದ್ರೆ ಈ conductor ಮಾತ್ರ move ಆಗುತ್ತೆ to and fro, right? So this is moving with velocity v, right? So that velocity will be taken as v is equals to dx by dt, right? So another form to derive the relation, that is induced EMF E across the ends of the conductor, that is P and Q. So E ends alli namage EMF induce ಆಗ್ತಾ ಇದೆ, ಅದರ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಇರುತ್ತೆ ನಮಗೆ BLV. So another method, that is by using the Lorentz force, right? So moving charges and magnetism alli discuss ಮಾಡಿರೋದು Lorentz force F, that is equals to QE plus Q into V cross B, right? So where QE is the electrical force, that is force due to the electric field FE plus FB, right? So this force is the magnetic force, right? So by using this magnetic force, because the conductor which is placed in the uniform magnetic field B, right? So the magnetic force FB, that is equals to QVB, right? So now ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, ಈ ಕಂಡಕ್ಟರ್ ನ ಮೂವ್ ಮಾಡ್ತಾ ಇದೀವಿ ಇನ್ಸೈಡ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಈ ಕಂಡಕ್ಟರ್ ನ ಮೂವ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಇಟ್ ಚೇಂಜಸ್ ಇಟ್ಸ್ ಪೊಸಿಷನ್. ಸೊ ಪೊಸಿಷನ್ ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ಇದು ಮೂವ್ ಆಗಬೇಕಂದ್ರೆ ನಾವೇನ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು, ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಸೊ ಡ್ಯೂ ಟು ದ ಫೋರ್ಸ್ ಇಟ್ ಚೇಂಜಸ್ ಇಟ್ಸ್ ಪೊಸಿಷನ್. ಸೊ ಫೋರ್ಸ್ ಇದೆ, ಜೊತೆಗೆ ಡಿಸ್ಪ್ಲೇಸ್ ಕೂಡ ಆಗ್ತಾ ಇದೆ. ಸೊ ಅಲ್ಲಿಗೆ ಏನಾಗುತ್ತೆ, ವರ್ಕ್ ಡನ್, ರೈಟ್? Work done by the conductor, that is equals to F into X, right? So force into displacement, right? So force ಏನಿದೆ ನಮಗೆ QVB into X, right? Let's give L tone, that is charge. So here we consider the charge, so that's why we taken L, right? QVB into L, right? So next, work done by the conductor ಏನಿದೆ QVB into L. So work done ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ potential ಇರುತ್ತೆ. So potential is nothing but EMF, that is force by length, that is relation between V and E, right? So EMF E, that is equals to work done by length, right? That is equals to QVB into L divided by L, right? So again we get E is equals to QVB. So is another method, that is by using Lorentz force, right? So general ಆಗಿ ತಗೊಂಡ್ರೆ previous class ಅಲ್ಲಿ ನಾವು ಏನು ಡಿರೈವ್ ಮಾಡಿದ್ವೋ ಅದೇ ಡಿರೈವೇಶನ್ ನ ನಾವು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಬರಿಬೇಕು. In case if they ask in terms of Lorentz force, we need to use this relation, right? So here we are considering the charge which is moving from point P to Q, Q. So ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಚಾರ್ಜ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ. When it is moving in an external field. So external field ಅಲ್ಲಿ ಚಾರ್ಜ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ಅಲ್ಲಿಗೆ ಫೋರ್ಸ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಆ ಫೋರ್ಸ್ ಏನಿರುತ್ತೆ ನಮಗೆ ಲಾರೆಂಟ್ಸ್ ಫೋರ್ಸ್ ಅಲ್ಲಿ, that is QVB, right? So work done by the conductor again into displacement. So force ಮತ್ತೆ displacement. So displacement ಎಷ್ಟಿದೆ? Length L ಅಷ್ಟಿದೆ, right? So QVB into L. So EMF induced E, that is equals to work done by L. So this work done is stored as the potential. So ಇದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ? Potential ಅಂತಾನೂ ಕರಿತೀವಿ. So relation between E and V, that is E is equals to V by L. So directly we can write that one as W by L, right? So QVB into L by L get cancelled. So E is equals to QVB. So ಎರಡು ರಿಲೇಷನ್ ನಮಗೆ ಸೇಮ್ ಬರುತ್ತೆ, ಮೆಥಡ್ ಏನಿದೆ ಡಿಫರೆಂಟ್, ರೈಟ್? So next, energy consideration. So external loop ಇದೆ, ಒಂದು ಲೂಪ್ ನ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡಿದ್ರೆ ನಮಗೆ ಅಲ್ಲಿ ಏನು ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ, ಏನು ಇಂಡ್ಯೂಸ್ ಆಗುತ್ತೆ? ಕರೆಂಟ್ ಇಂಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ದಟ್ ಈಸ್ ಅಗೇನ್ ಫ್ರಮ್ ದ ಫ್ಯಾರಡೆ ಲಾ, ರೈಟ್? ಸೊ when a conductor is placed in an external field, so current ಏನಾಗುತ್ತೆ? ಇಂಡ್ಯೂಸ್ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ current which is flowing from P to Q. ಸೊ current ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಫ್ಲೋ ಆಗ್ತಾ ಇರುತ್ತೆ, ಚಾರ್ಜಸ್ ಫ್ಲೋ ಆಗ್ತಾ ಇರುತ್ತೆ, ರೈಟ್? So charges flow ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ current, right? So current in the conductor, directly I will write current. So in which conductor? That is the conductor PQ. So current flow ಆಗ್ತಾ ಇರೋ conductor ಯಾವುದು? PQ. So here one more consideration we taken, the resistance of the conductor is R. So R PQ ಅಲ್ಲಿ resistance ಇರುತ್ತೆ, ಅದನ್ನ ನಾವೇನಂತ ತಗೊಳ್ತಾ ಇದೀವಿ? R ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದೀವಿ. Remaining all other arms, that is PS, that is equals to SR, that is equals to RQ. So taken negligible resistance. So motional EMF ಅಲ್ಲಿ ಇದು ಒಂದೇ ಮೂವ್ ಆಗ್ತಿರೋದ್ರಿಂದ we consider the resistance of the conductor as R, all other remaining arms as negligible resistance. Hence the overall rectangular loop having the resistance, that is R. So ಈ complete resistance ಏನಿರುತ್ತೆ ಈ ಲೂಪ್ ಅಲ್ಲಿ ಅಂದ್ರೆ R ಅಷ್ಟಿರುತ್ತೆ, right? So current which is flowing in the conductor, right? So that is given by I is equals to E divided by R. That is from the Ohm's law. V is equals to IR. So in place of V we can write E. So electromotive force is nothing but voltage, right? So I is equals to E by R. So here we have the relation I is equals to, so E ಗೆ ಏನಿದೆ ನಮಗೆ BLV divided by R. So this is the conductor, again from moving charges and magnetism. When a conductor carrying current which is placed in a magnetic field, then this conductor experiences the force, right? So ಯಾವುದೋ ಒಂದು ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ, ಅದು ನಮಗೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡಿದ್ರೆ it experiences what? Force, right? So that force is given by BIL, where L is the length of the conductor. ಸೊ ಇದನ್ನು ಕೂಡ ನಾವು ಡಿರೈವ್ ಮಾಡಿದ್ವಿ. ಯಾವುದಾದ್ರೂ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ, ಅಂತ ಕಂಡಕ್ಟರ್ ನ ಎಕ್ಸ್ಟರ್ನಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡಿದ್ರೆ ಆ ಕಂಡಕ್ಟರ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸಸ್ ದ ಫೋರ್ಸ್. ಸೊ ದಟ್ ಫೋರ್ಸ್ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು BIL, ರೈಟ್? ಸೊ ಫೋರ್ಸ್ experienced by the conductor PQ. So current in the conductor PQ, right? So only we consider this arm PQ ಅನ್ನೋ arm ನ ಮಾತ್ರ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿರೋದ್ರಿಂದ, so that experiences what? Force, right? So that is F is equals to BIL, where L is the length of the conductor. So here we know the value of I, so substitute here. So take on this one as first equation from equation 1. right? So now this we can take equation 2, B L V divided by R into L. So this is from equation 2. So multiply ಮಾಡಿದ್ರೆ B square L square V divided by R. So that is the force which is experienced by the conductor, right? So now we are moving this conductor. ಈ ಕಂಡಕ್ಟರ್ ನ ನಾವೇನ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಮೂವ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಮೂವ್ ಮಾಡಿದ್ರೆ ಮಾತ್ರ ನಮಗೆ ಯಾವ ಫೋರ್ಸ್ ಸಿಗುತ್ತೆ? ಎಲೆಕ್ಟ್ರೋಮೋಟಿವ್ ಫೋರ್ಸ್, ದಟ್ ಈಸ್ ಮೋಷನಲ್ EMF ಸಿಗುತ್ತೆ, ರೈಟ್? ಸೊ ಆಸ್ ವಿ ಆರ್ ಮೂವಿಂಗ್ ದಿಸ್ ಕಂಡಕ್ಟರ್, ಸೊ ಮೂವ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಅದರಲ್ಲಿ ವರ್ಕ್ ಡನ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ವರ್ಕ್ ಡನ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ಏನ್ ಜನರೇಟ್ ಆಗುತ್ತೆ? ನಮಗೆ ಪವರ್. ಸೊ ವಿ ನೀಡ್ ದ ಪವರ್ ಟು ಮೂವ್ ದಿಸ್ conductor. So namge power required to move the conductor PQ, right? Power required to pull the conductor PQ in the magnetic field, right? So ಎಷ್ಟು ಪವರ್ ಯೂಸ್ ಆಗ್ತಾ ಇದೆ ಇದನ್ನ ಕಂಡಕ್ಟರ್ ನ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಮೂವ್ ಮಾಡೋದಕ್ಕೆ, right? So that is given by P. So power is denoted by P. Again from first year, power in terms of force and velocity, that is F into V. So power is equals to force into velocity. So move ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ that conductor has some velocity. So again we have the force relation, that is B square L square V divided by R into V, right? So power is equals to B square L square V square divided by R. Following this third equation, right? So from Joule's law of heating, right? So conductor ಅಲ್ಲಿ current flow ಆಗ್ತಾ ಇದೆ. So conductor ಅಲ್ಲಿ current flow ಆಗ್ತಿರೋದ್ರಿಂದ conductor ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ? Heat ಆಗ್ತಾ ಹೋಗುತ್ತೆ, right? So from Joule's law of heating, so that we taken power in terms of joules. So Joule's law of heating ಅಲ್ಲಿ power in terms of joules, that is equals to I square R, right? ಇದು ನಾವು ಕರೆಂಟ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿದೀವಿ, ಪವರ್ ಎನರ್ಜಿ, right? So from the first relation, second relation I, we have B L V divided by R whole square into R, right? So from this we can write B square L square V square divided by R. So that becomes the fourth equation, right? So now observe equation 3 and equation 4, right? So square model B square L square V square divided by R square. So numerator one R is there, R and R square get cancelled, so in the denominator we getting R, right? So from equation 3 and 4, so equation 3 and 4 ಅಲ್ಲಿ first ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ? ಕಂಡಕ್ಟರ್ ನ ಮೂವ್ ಮಾಡ್ತಾ ಇದೀವಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಒಳಗೆ. That means we are applying mechanical energy, right? So due to this mechanical energy, current is produced in the conductor, right? So mechanical energy is converted into electrical energy, right? So this electrical energy is changes into the thermal energy. That means the current which is flowing in the conductor gets heated, right? So that is again from the law of conservation of energy, changing from one form of energy to another form of energy, right? So from equation 3 and 4, so from equation 3 and 4, so ಎರಡು equation ಅಲ್ಲಿ ನಮಗೆ values ಏನು ಬರ್ತಾ ಇದೆ? Same ಬರ್ತಾ ಇದೆ. One is mechanical energy and another one is thermal energy. So thermal energy is like heating energy, right? So from equation 3 and 4 mechanical energy is converted into electrical energy and then to thermal energy. So this one is the conclusion, right? ಸೊ ಮೆಕ್ಯಾನಿಕಲಿ ಕಂಡಕ್ಟರ್ ನ ಮೂವ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಎನರ್ಜಿ ಜನರೇಟ್ ಆಗ್ತಾ ಇದೆ. ಅದು ಯಾವ ಎನರ್ಜಿ ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ, ರೈಟ್? ಸೊ ಆಸ್ ದ ಕರೆಂಟ್ ವಿಚ್ ಇಸ್ ಫ್ಲೋಯಿಂಗ್ ಇನ್ ದ ಕಂಡಕ್ಟರ್ ಇಟ್ ಗೆಟ್ಸ್ heated up, right? So heat ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ again it convert electrical energy is converted into thermal energy, right? So that is from the relation 3 and 4. So we can prove the statement, right? Energy consideration. So this is about the motional EMF, right? So this is based on the quantitative, right? Just equations na use ಮಾಡ್ಕೊಂಡು concepts na explain ಮಾಡಿರೋದು, right? So ಇದರಲ್ಲಿ important definition ಮತ್ತೆ derivation. So the next one is eddy currents. Right. So what are eddy currents? So previous now discuss ಮಾಡಿದ್ದು EMF which is induced in a conductor, that is across the conductor when which is placed in a magnetic field. So magnetic field ಅಲ್ಲಿ conductor ನ place ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ EMF induce ಆಗ್ತಿದೆ. So ಅದನ್ನ ನಾವು ಏನಂತ ಕರೆದ್ವಿ? Motional EMF ಅಂತ ಕರೆದ್ವಿ, right? So same as here we have current. So your current eddy current, that means when a thick conductor which is placed in an alternating magnetic field, that means varying magnetic field ಅಲ್ಲಿ ನಾವು ಯಾವುದಾದ್ರೂ ಒಂದು ಕಂಡಕ್ಟರ್ ನ ಪ್ಲೇಸ್ ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ ಕರೆಂಟ್ ಇಂಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಸೊ ಅಂತ ಕರೆಂಟ್ ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ? ಎಡ್ಡಿ ಕರೆಂಟ್ಸ್, ರೈಟ್? The current induced in a thick conductor when placed in a varying magnetic field. So magnetic field ಏನಾಗ್ತಾ ಇದೆ? Every time change ಆಗ್ತಾ ಇದೆ. That we call as varying magnetic field. So varying magnetic field ಅಲ್ಲಿ thick conductor na now place ಮಾಡಿದ್ರೆ that means its resistance is less, right? So when we place the conductor in a varying magnetic field, then the current is induced in the conductor, right? So that current we call as eddy current, right? So the conductor having less resistance, hence the magnitude of the eddy current is more, right? So the magnitude of eddy current is more because the conductor having less resistance. So conductor ಅಲ್ಲಿ resistance ತುಂಬಾ ಕಮ್ಮಿ ಇರುತ್ತೆ. So hence eddy current magnitude, that means eddy current value ಯಾವಾಗಲೂ ಏನಿರುತ್ತೆ? ಜಾಸ್ತಿ ಇರುತ್ತೆ, right? So we need to minimize that eddy current, right? So that is unwanted current in case of the transformer. So ಇದ್ರದ್ದು disadvantage ಕೂಡ ಇದೆ, ಜೊತೆಗೆ advantage ಕೂಡ ಇದೆ, right? So ರೆಸಿಸ್ಟೆನ್ಸ್ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ತುಂಬಾ ಕಮ್ಮಿ ಇರೋದ್ರಿಂದ ಎಡ್ಡಿ ಕರೆಂಟ್ ಏನಾಗ್ತಾ ಇದೆ? ನಮಗೆ ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ. ಸೊ ಹೌ ಟು ಮಿನಿಮೈಸ್ ದೀಸ್ ಎಡ್ಡಿ ಕರೆಂಟ್ಸ್, ರೈಟ್? ಸೊ ಟು ಮಿನಿಮೈಸ್ or to reduce the eddy current, lamination to minimize the eddy current by doing lamination to the conductor, right? In other words, so eddy current na ನಾವು ಮಿನಿಮೈಸ್ ಮಾಡಬೇಕು, ಕಮ್ಮಿ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಏನು ಮಾಡಬೇಕು, ನಮಗೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ನ ಜಾಸ್ತಿ ಮಾಡಬೇಕು. ಸೊ ರೆಸಿಸ್ಟೆನ್ಸ್ ಯಾವ ತರ ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಇದ್ವಿ, ದಟ್ ಈಸ್ ಬೈ ಡೂಯಿಂಗ್ ಲ್ಯಾಮಿನೇಟಿಂಗ್. ಸೊ ಲ್ಯಾಮಿನೇಷನ್ ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, ರೈಟ್? ಸೊ ದಟ್ ಈಸ್ ಒನ್ ಮೆಥಡ್ ಟು ರೆಡ್ಯೂಸ್ ದ ಎಡ್ಡಿ ಕರೆಂಟ್ಸ್, ರೈಟ್? So next one point is that eddy currents are undesirable in case of transformer, right? So now transformer discuss ಮಾಡಬೇಕಾದ್ರೆ losses in the transformer study ಮಾಡಬೇಕಾದ್ರೆ ಇದು ಕೂಡ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಇತ್ತು, ದಟ್ ಈಸ್ ಎಡ್ಡಿ ಕರೆಂಟ್. ಡ್ಯೂ ಟು ಎಡ್ಡಿ ಕರೆಂಟ್ ದೇರ್ ಇಸ್ ಎ ಲಾಸ್ ಇನ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್, ರೈಟ್? ಸೊ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಅಲ್ಲಿ ಐರನ್ ಕೋರ್ ಇರುತ್ತೆ, ಇದನ್ನ ನಾವು ಲಾಸ್ಟ್ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಸೊ ದಿಸ್ ಕೋರ್ ಈಸ್ wounded with the coils. So one is primary coil and second one is the secondary coil, right? So iron core ಗೆ ನಾವು ಏನು ಮಾಡಿದ್ವಿ, coils ನ ಉಂಡ್ ಮಾಡಿದ್ವಿ. So coil ಉಂಡ್ ಮಾಡಿದಾಗ when an alternating source is subjected to the coil, so alternating current ನ ನಾವು ಈ coil ಗೆ ಇಂಡ್ಯೂಸ್ ಮಾಡಿದಾಗ ಇಲ್ಲಿ ಏನು ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಸೊ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ that magnetic flux will link to the secondary coil and hence current is produced. That means we are converting the high voltage to the low voltage and high current to the low current, and also low voltage to high voltage and low current to high current, right? So here the iron core which is wounded on the coil. So iron core ಮೇಲೆ ನಾವು ಏನು ಮಾಡಿದೀವಿ, coil ನ wound ಮಾಡಿದೀವಿ. So from this concept, so ಇದರಿಂದ ಏನಾಗ್ತಾ ಇದೆ, when the current is flowing in the coil, so here it produces the eddy current. So eddy current ಏನು produce ಆಗ್ತದೆ, so on this iron core, right? So iron core ಅಲ್ಲಿ eddy current produce ಆಗೋದ್ರಿಂದ so there is a loss, right? So ಇಲ್ಲಿ ನಾವು 5 amperes ಅಷ್ಟು current ನ ಸೆಂಡ್ ಮಾಡ್ತಾ ಇದ್ರೆ ಸೊ ನಮಗೆ ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ಇಲ್ಲಿ 5 amperes ಅಷ್ಟು ಕರೆಂಟ್ ಬರೋದಿಲ್ಲ, ಅದಕ್ಕಿಂತ ಕಡಿಮೆ ಬರ್ತಾ ಇರುತ್ತೆ. ಸೊ ದಟ್ ಮೀನ್ಸ್ there is a loss in the transformer, that means the power loss. So I value reduce ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ power loss, because the relation is I square R, right? So ಎಷ್ಟು loss ಆಗ್ತಿದೆ, that gives the relation I square R, right? So that is one demerits of the eddy currents, right? So that's why eddy currents are undesirable in case of transformer. That is because energy loss in the form of heat, right? So energy ಏನಾಗ್ತದೆ, ನಮಗೆ ಲಾಸ್ ಆಗ್ತದೆ ಯಾವ ಫಾರ್ಮ್ ಅಲ್ಲಿ, ಹೀಟಿಂಗ್. ಸೊ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ನಮಗೆ ಹೀಟ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ ಕಂಡಕ್ಟರ್ ಇರೋದ್ರಿಂದ. ಸೊ there is a loss, right? So this is one disadvantage of the eddy current, right? So only one disadvantage. So disadvantage of the eddy current is it is undesirable in case of transformer. So undesirable means unfit in case of the transformer, right? So unnecessary ಆಗಿ ನಮಗೆ ಏನು ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ, ಹೀಟ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ. So next, advantages. So first advantage in magnetic braking in trains, right? Second one, induction purlins, right? Third one is electromagnetic damping, and the last one is electric power meters. Right? So these are the advantages of eddy currents, right? So ನಮಗೆ eddy currents definition ಕೇಳಬಹುದು ಜೊತೆಗೆ advantages ಕೇಳಬಹುದು, right? So mention two advantages of eddy currents. 2019 ಅಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ, mention the advantages of eddy currents 3 marks ಗೆ. So 3 marks ಗೆ ಕೇಳಿದ್ದಾರೆ ಅಂದ್ರೆ just you need to write the statements, right? So that is magnetic braking in trains. So magnetic rails irutara, rails means track. So on the magnetic tracks they mounted the electromagnets, right? So it works only in the electric trains. So yav electric trains work aagta iruto, so anta kadege we are using the magnetic braking system. So we continue in our next class. Thank you.